Hello everyone, this is Om Prakash. I am from Institution of Aeronautical Engineering College from CSIT branch. My ATT concept video topic is limits of a function. The limits of a function. Let's investigate the behavior of the function f defined by f of x equals to x square minus x plus 2 for values of x near 2. Limits of a function numerically. The following table gives values of f of x for values of x close to 2 but not equal to 2. If the value of x is 1.0, then the value of f of x is 2.0. If x is 1.5, then f of x is 2.75. If x is 1.8, then f of x is 3.44. If x is 1.9, then f of x is 3.71. If x is 1.95, then f of x is 3.85. If x is 1.995, then f of x is 3.98. If x is 1.999, then f of x is 3.997. If x equal to 3.0, then f of x is 8.00. If x is 2.5, then f of x is 5.75. If x is 2.2, then f of x is 4.64. If x is 2.1, then f of x is 4.31. If x is 2.05, then f of x is 4.15. If x is 2.01, then f of x is 4.03. If f of x is 4.01. If x is 2.001, then f of x is 4.003. Limit of a function graphically. From the table and the graph of a parabola shown in figure 1, we see that when x is close to 2 on either side of 2, f of x is close to 4. This is the graph of f. Here we take an f of x approaches 4 on y-axis, x approaches 2 is taken on x-axis. As x gets close to 2, f of x gets close to 4. The limit of the function f of x equals to x square minus x plus 2 as x approaches 2 is equal to 4. The notation for this is limit x tends to 2 of x square minus x plus 2 equals to 4. Definition for limit of a function. We write limit x tends to a f of x equals to L and says the limit of f of x as x approaches a equals L. If we can make the values of f of x arbitrarily close to L, as close to L as we like by taking x to be sufficiently close to a on either side of it but not equal to a. An alternative notation for limit extends to a f of x equals to L is f of x extends to L as x extends to a, which is usually read f of x approaches L as x approaches a. Notice the phrase but x not equals to a in the definition of limit. This means that in finding the limit of f of x as x approaches it, it does not matter what is happening at x equals to a. In fact, f of x need not even be defined when x equals to a. The only thing that matters is how f is defined near a. Figure 2 shows the graphs of three functions. Note that in part C, f of a is not defined and in part B, f of a not equal to L. But in each case, regardless of what happens at a, it is true that limit extends to a f of x equals to L. These are the graphs of three functions. Here, limit extends to a f of x equals to L in all three cases. Example 1. F of x equals to x minus 1 by x square minus 1. Find limit x tends to 1. F of x. This is the example 1 graph. Here 0.5 is taken on y-axis and 1 is taken on x-axis. Guessing a limit from numerical values. Guess the value of limit x tends to 1, x minus 1 by x square minus 1. Solution. F of 1 is undefined, but that does not matter because the definition of limit is limit x tends to a. F of x says that we considered values of x that are close to a but not equal to a. Numerically, the tables below give values of f of x correct to 6 decimal places. For values of f of x that approaches 1 but are not equal to 1. If 0.5 is less than 1, then f of x is 0.66. If 0.9 is less than 1, then f of x is 0.52. If 0.99 is less than 1, then f of x is 0.50. If 0.99 is less than 1, then f of x is 0.500. If 0.99, then f of x is 0.500. If 1.5 is greater than 1, then f of x is 0.40. If 1.1 is greater than 1, then f of x is 0.47. If 1.01 is greater than 1, then f of x is 0.49. If 1.001 is greater than 1, then f of x is 0.499. If 1.0001 is greater than 1, then f of x is 0.4999. On the basis of the values in the tables, we make the guess that limit x tends to 1, x minus 1 by x square minus 1 equals to 0.5. Now let's see one-sided limits. One-sided limits. The Heaviside function h is defined by h of t. 0 if t less than 0. 1 if t greater than or equal to 0. H of t approaches 0 as t approaches 0 from the left and h of t approaches 1 as t approaches 0 from the right. We indicate this situation symbolically by writing limit t extends to 0 power minus h of t equals to 0. Limit t extends to 0 plus h of t equals to 1. T extends 0 power minus values of t that are less than 0 left. T extends to 0 power plus values of t that are greater than 0 right. Definition for one-sided limits. We write limit x tends to a power minus f of x equals to L and say the left hand limit of f of x as x approaches a, or the limit of f of x as x approaches a from the left is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a and x less than a. Notice that definition 2 differs from definition 1 only, in that we requires x to be less than a. Similar definition for right-handed limit. Overall limit exists if both one-sided limits exist and they agree. Limit x extends to a, f of x equals to L, if and only if limits x extends to a power minus f of x equals to L and limit x extends to a plus f of x equals to L. One-sided limits from a graph. The graph of a function g is shown in figure 10. Use it to state the values if they exist of the following. A. Limit x extends to 2 power minus g of x. Limit x extends to 2 power plus g of x. C. Limit x extends to 2 g of x. D. Limit x extends to 5 power minus g of x. E. Limit x extends to 5 power plus g of x. F. Limit x extends to 5 g of x. This is the graph of one-sided limit. Solution for one-sided limit. From the graph, we see that the value of g of x approach 3 as x approaches 2 from the left, but they approach 1 as x approaches 2 from the right. Therefore, A. Limit x extends to 2 power minus g of x equals to 3, and B. Limit x extends to 2 power plus g of x equals to 1. Since the left and right limits are different, we conclude from 3 that limit x extends to 2 g of x does not exist. The graph also shows that the limit x extends to 5 power minus g of x equals to 2, and E. Limit x extends to 5 power plus g of x equals to 2. This time the left and right limits are the same, and so by 3 we have limit x extends to 5 g of x equals to 2. Despite this fact, notice that g of 5 is not equal to 2. Example for one-sided limit. To find left and right overall limit at x equals to minus 4, x equals to 1, and x equals to 6. And this is the graph for left and right overall limit. Thank you for everyone giving this great opportunity for me.